In this video, I'm going to build a cold cathode neon readout tube clock, commonly called a Nixie tube clock, because it uses cold cathode neon tubes to form the numbers. And how it works is your cathodes are shaped like your numbers with a mesh anode. There's a high voltage discharge placed between the cathode and the anode, and the cathodes glow. They are very unique, dates back to about 1955, very cool. I'm building one. Let's watch. Fresh on the heels of building my dot matrix Banggood clock, I received a package, and this one's got me all excited. Can you see? This came from the UK, and that can only mean one thing. This is the prize I've been waiting for. Haven't even opened it yet. Look at this. Got lots of, this one came to me from PV Electronics. Has a little circuit board here. And what else is in here? Let's get rid of the styro chips. This looks really old. It's very old and very moldy. Like it's been sitting in a bunker somewhere for the past 50 years. It's a Nixie tube clock. Isn't that cool? Good old Soviet Nixie tubes. These are originals. These are old as the hills. I'm going to put this back in this package for safekeeping until I'm ready to install it in the clock. But here we have a 6-digit Nixie tube clock. I'm already getting excited. I've wanted to build one of these for years. As I think I mentioned in my last video, I even went to the trouble of finding one at Ramsey Electronics, and it was all set to buy one. And then Ramsey stopped selling kits. They went out of the kit business before I was able to get one, which had me kind of annoyed. But I found one at PV Electronics. I ordered it a couple weeks ago. It arrived today, and that is going to be this video. We're going to build this Nixie tube clock kit. Unlike the Banggood, it doesn't come with a nice case, but I think I have something to put this in already. My nice little vacuum fluorescent display clock that I've got the VU meter in below. I may have to remove the VU meter and the vacuum display clock, because I think a Nixie clock in that case with that nice black glass is going to look spectacular. So I think this is going to be my Nixie clock case. And it just so happens that the PC board is exactly the right size to fit inside there. So I think that will look fantastic. So when it's built, it's going to go in this case, and I'm going to have to find something else to put those modules in. So here's the instruction manual, assembly instructions and user guide. I printed it in color because I'm going to probably want to hang on to this. It's about 35 pages long. Just gives you all the warnings, like it has 170 volts DC, so you can get a good jolt from it. Here's our list of components. This is what I'm interested in. Okay, according to the instructions, the first thing I'm going to install is the tube sockets And they've got two different types of sockets. They got silver sockets and gold sockets, and these ones here look to be the gold pins. So the process for this is a little different. It's telling me to actually get the Nixie tube out. For the iron 8, slide 11 sockets onto the 11 pins of the tubes. Insert the tube with the socket into the PCB, noting the white marking on the side from the sockets should be inserted. This is the side that's marked. Insert tubes from the side. Yeah, I think. So I'm just going to place the pins over the tube pins. Push them all the way down. There's 11 pins. Of course, you've got your 10 numbers plus your anode, right? So you have 11 pins. Okay. And now we'll fit that into the board here, onto the board itself. And then the pins fit down like that onto the board. And then I'm going to make sure it's level and just start soldering them in from the other side. That's the reason they have us do that, is I take it the other sockets have a retainer, so you can just set the whole socket in and solder them down, whereas this one here, it's just pins sticking out of the board. So you don't want to put the loose pins in and solder them in and have an alignment problem, which would cause stress on the glass if you tried to insert the tube. This way we put the pins on the tube, insert the pins into the circuit board, solder it in place, and that way there's no stress for when you unplug and plug the tubes. So let's solder this one in. So we'll proceed to solder in the tubes. I'm just going to hold the tube straight and try and get this thing in here fairly straight. This could prove to be a challenge. I imagine once I get a couple of them in, it'll hold it in place. I'll just get a couple pins soldered in here. Once I get a couple soldered down, it'll hold the tube. It'll hold the rest of the pins relatively straight so that I can do the rest of them. There. That looks to be pretty straight. Yeah, okay, that tube is in straight. So now I can turn it over and I can do the rest of them. And then I can remove the tube and move over to the next one. So let's just continue. Just going to get my magnifying glass in the way here so that I can see exactly what I'm doing. Maybe zoom the camera in a bit for you guys too. just going to give my iron just a little bit more heat because this thing is, we're soldering some pretty good sized pins here, so I don't have to worry so much about damaging any SMD parts. These are tube sockets, but the fact that the tubes themselves are hooked up to it, or it's plugged into a tube, but they're acting like a heat sink and it's drawing the heat away. So I'm just going to put the iron temperature up a little hotter. Try and get a little bit better flow on these tubes. We're good there. Okay, now I can remove this tube and this one's soldered in place. Just like that. Okay, now we get to the next one. We'll do the same for the next tube. So, okay, that has it. That's all of the Nixie tube sockets are installed. I'm going to remove the tube now and I'll wrap it back up for safekeeping until I'm ready to install it. First we'll check the socket to make sure that there's no shorts between any of the pins. So we just check each adjacent pin with each other. And I've done the same for the other four. So there's no bridges or any shorts on any of these pins. These are ready to go. Next page. First component to install is the J1 fuse. So our components all install on this side because you don't want any parts sticking up blocking the view. So all the components go on the bottom side of this board. So I'm looking for J1 for the fuse, and it should be marked on the board here. The fuse goes in here. This is a self-resetting fuse. So that goes in there, and J1 is the input, power input, so we'll put J1 and the fuse in like that, and we'll attach them to the board on this side. I'll tell you, this one's going to be a lot easier to do than the last one, which was all surface mount. Man, the surface mount stuff is can be tedious to work on. So it's a real pleasure to be working with through-hole components again. Just makes things a little bit easier to deal with. Okay, J1's installed. Now we're going to install D1, D2, and D3. They're two different sizes of diodes here, so I got to look these up here. Where are these? I got a couple diodes here. 1N5819. There's the 5N19s right there, and they go in D1 and D3. So here's D1 and D3. Note the band position is marked. There's the 7805 there. Note the orientation, the heat sink faces back, and it looks like they're having it bent over. So they're bending it over like this. So C1 and C2 are these little 100 nanofarad ceramic capacitors. So these go down on the board there. As you can see, the 5-volt regulator is working because we have 5.7 volts. So the 5-volt regulator is regulating this power supply down to 5 volts. Okay, now it's time to start working on the high voltage generation circuit. So we're going to mount the socket for IC2, which is that one there. Mount the socket in here and tack it down. Now it's time to mount R1 and R3, which are 4.7 k ohm resistors. That'll be a yellow, violet, orange. So I've got 2 of them here. So R1 and R3. R3 is here, and R1 is over here. These are going to have to stand up on the board because there's no room to lie them flat. So they're going to go in like that. R2 and 4 go over here right next to the other two, and again they're mounted in the same manner. Bend the leads over the top and mounted flush down to the board. Okay, a C3, which is a 1 microfarad at 250 volts. This will be it here. 1 microfarad, 250 volts. This is the high voltage capacitor. And it is polarized, the positive lead being the longer one. It's marked with a plus on the board. And it's a high quality Matsushita electrolytic capacitor. Next will be Q1, which is an IRFD 220, which is a transistor. It's going to look like a little IC. It's a MOSFET. Yep, that's it, IRF. So it goes in Q1. The joined pins are even labeled. So basically it's 4 pins, but 2 of them are joined together. So these 2 here are 1 pin. They go in to here like this. And then there'll be a 100 microhenry inductor. That's going to be this big bugger here. That's going to be L1. L1 goes in right here. See, what this does is this is a buck converter. So they oscillate and use an inductor to boost the voltage up. It's not using a full transformer as a switching power supply would, because you don't need a lot of current with this. So they're just using a boost converter to bump up the voltage for the Nixie tubes. D4 is a UF4004, so let's find that diode. Got it, first guess. That's D4. D4 is right in here. Again, the cathode's marked with a band on the board here, so That goes in like that. Pull that down tight. D5 is a 62 volt Zener diode. So that's D5. D5 goes in right down here. Yeah, turn up the page here, page 15. No, I'm sitting on page 15. And all the resistors need to be mounted upright to save space. Yeah, I think I already figured that out. So now it wants me to install we're going to test the high voltage, so we're going to install the IC for the high voltage generator. Okay. The IC is in now. And it says, refer to the warnings, you think. Power up the PC board and test between the ground and the high voltage test points, and it should be measuring between 167 and 173 volts. And now we'll test the high voltage generation circuit and see whether we get our 160, 170 volts, I think is what it's supposed to be. Between 167 and 173 volts is what we should have. So let's plug this thing in here and watch a bunch of smoke come out of it. Okay. Ground to the ground point, high voltage 166 volts, so that tells me that the high voltage generator is working. We'll just let that capacitor discharge here. It should discharge relatively quickly, I would think. Yeah, it is, because it's not a real efficient converter. So now we'll pull the pick out so that I can put that back into its anti-static bag. Or anti-static foam, I should say, so that it doesn't get damaged. And now we can work on the rest of the project. So as we continue, we've got more components in the high voltage circuit to mount next. So next is R5 and R9 through 11 and R18 through 23. There's 4.7K resistors. So let's find the 4.7K resistors. Here they are again. And we'll start populating R5 and then R9 through 11. So R5 is over here. The construction on this is almost exactly the same as it was for the ice tube clock that I built a year or two ago, which was the VFD clock that used the Russian 8-digit VFD display. It's almost the same circuit. It used a similar buck converter to generate the high voltage that the VFD display requires, but it only needs like 45 volts, not 179 like this thing needs. But the circuitry here, this part is very, very similar. It's using a PIC as well with an oscillator on it, and driving a MOSFET and a little inductor. So that part of the circuit is very similar. So R9 through 11, so 9, 10, and 11. So I'll get 3 of them out here. There's 3 of them here. And there's 9, 10, and 11. So 9 is here. next one over is 10. I haven't found 11. Oh, there's 11 over here beside Nixie tube number 2. So 11 is here. And 10 is right over here. So that's 9 through 11. Now R18 through 23. There's 22, 21, 20. R18, there we go. Okay, that's got those, and then we're going to go to 390k ohm resistors for 12, 13, and 14. So 390k, 390000. That's it there. Okay, so that's for our 12, 13, and 14. Get 3 of those in a row here. And R13 is next to it, over here. Now you notice when I stand these up like this, I never put the conductive leads next to each other so that if they got bent they could short. I always put the body of the next resistor next to the, if you look here, next to the put the body next to the lead for the next resistor. So that way it prevents any short circuits if the resistor were to get bent, which isn't going to happen because this thing's going to be installed in a wooden case when I'm done. But I'm doing it just to prevent any chance of of shorts. I got to be careful when I'm working in here because I just touched one of those tube sockets with some solder and it'll stick to it. Okay, next one is the 10k ohm for R15, 16, and 17. That'll be a brown, black, orange. So there's 3 of them, and that is R15, R16, and R17. So here they are. 15 is here, 16 is there, and 17 is over there. Okay, now we have 3 transistors. Actually, we have 6 transistors to mount, but I'm going to find the MPS A42, and we'll put those ones in first. So MPS A42, that's 1. It's 2. And Q6 goes next to it. And they only go in one way. They are silkscreened the direction that they go in. Q8, 9, and 10 is the MPS A92s. So let's find those ones. It should be these ones here. MPS, where is it? A. So they go into 8, 9, and 10, which is next to the other ones. So there's 8 here. Okay, and now we have C5, which is a 15 picofarads. Let's find what that one is. I should say 15 on it. There's C5 there. These ones are not polarized, by the way. And C6 is the 33. So we just drop those two in. So basically the IC that's in here, it does two things. One, it's the actual clock, the program. But the second thing it does is it generates the high voltage, which is the same as my ice tube clock, the vacuum fluorescent it used a PIC as well, to generate both the high voltage and to be the actual timekeeping piece. And since this supports a GPS input, I might just invest in the GPS receiver for it to make it deadly accurate. The ice tube clock also supports GPS. I just never bothered to do it. But this one, I might do it on this one. 32 kilohertz crystal is next. There should be a little crystal in here somewhere. There it is. It scoots across the desk. And that goes into the board here where it's marked X1. This is the reference oscillator. And I gotta put socket for IC3. And there's the notch right there on the side. So it goes in just like that. And I have to solder that down. I'm going to tack in one pin just to hold it in place so that I can get the rest in. This is the high voltage driver IC. Probably the same one that the ice tube clock used. Looks similar. The socket is now mounted for IC3, and I'm going to test it now for basic functionality. It says now is the time to test the basic display functions that all tubes are working correctly. So we're going to insert IC 2 and 3 into the sockets. The IC's got a flat corner, so it only goes in one way. I'll just pop it down like that. And now that one is in. And we'll do the same for the other IC. So install all the tubes into their appropriate sockets. all the tubes are plugged in. If I put power to this thing is supposed to light up and start counting. There they go. Zeros. 1. This is exciting. 3, 4, 5, 6, 7, 8, 9. There they are. The tubes are working. Very cool. Okay, now we'll remove all the tubes and continue. So now we've removed the tubes again so that I can continue the build. We know that that part is functional. So now we're going to continue on and mount R6, 8, 29, and 34, which is a 270 ohm resistor. So let's dig out the 270 ohm resistors. Where are they? Okay, so R6 through 8, so 6, 7, and 8. Get those in there. This is going to go together pretty quick now because I've got most of the parts on the thing. It's 9/11. I've only been working on this for a few hours. It's not 30 degrees in here, by the way. If you see the temperature, it says 30 degrees. It's not 30 degrees. It's because my clock is sitting on top of the adapter for my soldering iron, so it's throwing the temperature off on this thing. But I like that. That little dot matrix clock really is cool. Okay, 6, 7, and 8 were 270 ohm, and then 29 through 34 are also the same size. So 270 ohms. So let's find those ones. (32, 33, and 34 are also the same value. And there you go, right up here. See 7, 9, and 10, there's 100 nanofarads. Where are they? I think that was these ones here, right? 104. The last three of these, little ceramic jobbies. 7, 9, and 10. And C8 is a 0.1 or a 0.22. What's left in here? Oh, wait a minute. C8. That's a big bugger. It's a 0.1 or 0.22 farad. That's it there. It's the super cap. This is the one that is used to back up the time and stuff in the event of a power failure. And this one will make a big spark, by the way, if you charge it up, because it only stores like I think it's 5 volts or something like that. Yeah, 5.5 volts. So there is a polarity on this, and it will go kaboom if you put it in the wrong way. So I'm just looking for the polarity marking on this thing here. Looks like it's got an arrow on it that tells me it goes in this way. There, that's the backup capacitor. Okay, now we've got the switches. The set and adjust an alarm, the DST switches. So there should be some switches here. Where's all these switches? Here's all the switches here. Let's see where they go. So we've got set and adjust alarm and daylight saving time switch. So here's the three. Here are the three switches here. Now, which side do they go on? They go on the same side as the component. So here we go. They go in like this. Okay, now we've got a couple yellow LEDs to go in. D6 and D7. Looks like they face out the back here. D6 and D7. Mount the two LEDs here, the yellow ones, D6 and D7. The positive is the longer of the two leads. So it looks like these are supposed to face out the back. Now it says the yellow is D6 and D7 and the green is D8. So here's the green one, although they're showing the green one over here. It shows that they're supposed to point out the back for some reason. Okay, and the buzzer, wherever the heck the little buzzer is, piezo buzzer, that's going to go LS1, which is right here. The GPS jack for if I were to put GPS on it, which you never know, just might do that at some point. The GPS jack is a surface mount jack that just attaches to the board. The tube lighting. Oh yes, we have some LEDs here. So start by clipping off the narrower diameter section of the two tube sockets as shown below. Just to take off the because we don't want to short out to the LED, that's why. So they want us to take off these pins. This is so that the blue LEDs, I think they're blue, can be put through these holes in the bottom here to light up the inside of the Nixie tubes to make them glow kind of a cool blue, which might look cool. So we're going to bend these things like that. And like that. That's so that these can go up through the bottom of the board here and go through these holes in the board and feed the LED up through the bottom of the Nixie tube like that. Okay, installing the blue LEDs, 2 of them here, got the other 4 to go. You have to make sure that these leads don't touch the tube socket, keep them well clear of the pins here, because the pins are going to have high voltage on them, and of course the LEDs don't operate at high voltage, so if you were to short them out, they'd have a bit of a problem. And that's why we shortened the first 2 pins, just to make sure that there was plenty of clearance. I think I'm down to the last. I got a couple transistors left to install after these, and I've got the AM PM indicators, which are little neon lights, which we're going to insert at the right height. They say they're the last pieces to put in, so that you can put them at the right height to correspond with the tubes. There's just 4 transistors left here, and I think that's all that there is. It's Q2, 11, 12, and 13. Q2, it's MPS A42, yep. Q2, Q11 and 12. There's 12. Is over here, and there'll be one more. The last one was right up there. I believe that has got all the components mounted. We've got a couple of resistors and a couple of LEDs left over because they said that the different parts are used in different kits, so there's a few extra parts for the different kits that would use more. And I see a piece of wire there I got to get out of the way before it shorts something out. I can just spot it there. A fragment of wire that was stuck down there. I believe that's the last of the components that is mounted on this thing. Okay, I've got my heat shrink tubing mounted. I'm going to turn on my heat gun. I'm going to shrink the heat shrink tubing down. To form a little stand for the neon bulb. There's one. We'll do the same for the other. So what I've done here is I've taken the neon bulb to insulate one of the leads. I'm just putting a little piece of its own tubing on there, and I'm sliding the whole assembly into a larger piece of heat shrink tubing. As you can see, I shrink that down. That'll provide a little base for the neon lamp to stand up from the board. We'll stand the AM/PM indicators up. We'll stand up about that high. And I'll just tack them down on the bottom. And then this thing's going to be ready for testing. There's my AM/PM indicators. Make sure that the bench is clear of any debris. And we have to, now there's a procedure that I have to go into to start this thing up. And how to operate the clock. Okay, the buttons have the following functions. Set exits the tube test routine on cold power up. It shows date, time set. Adjusts it, alarm, and DST toggles between daylight and standard saving time, plus or minus 1 hour. And so set exit test tube test routine. So we can plug this thing in now, and this thing should go into the test routine like it did before. Okay, which it does. And if I hit set, let's kill some lights in here so that we can actually see what this thing looks like. Now that is a Nixie clock. That looks very cool. Gotta like that. Definitely gotta like that. Let's set the thing. I can turn off the soldering iron now. You can see it with the other one I built yesterday in behind here. Okay, try not to get electrocuted because I don't have this thing in a case yet, but set and adjust and alarm and DST. So the set button is going to show, where's the set button? Here it is here. So goes to date, I guess. I hold it and it goes into setting mode. Adjust is the next one over. So that resets the seconds. Next one over is minutes. So I missed it by 1 here, so we'll just go to, we'll take it to 10:01. Here we go. And 10 o'clock. $10. Oh, I can do the seconds too. Now, how do I set AM and PM on this thing? Okay, access configuration. Press and hold the set button. After 2 seconds, the seconds will become highlighted. Continue holding the button for a further 2 seconds until the clock displays this format. 00XX99. 99 is the seconds as it tells you you're in the configuration menu. Okay, so hold and continue to hold for 2 more seconds. There we go. Okay, and then it'll say 00 and then a 2-digit number and then 99. And that tells you it's in the configuration. In this mode, the hours digit displays the current parameter being adjusted and the minutes displays the value stored against each parameter. Aha! Each parameter is referring to the table below. Scroll through the ranges possible by pressing the adjust button, and when desired has been reached, move on to the next parameter by pressing the set. So here's parameter 0 software version. Okay, one is 12 or 24-hour date format. So if I press the set button, I think it is. So 01 is either going to be 12 or 24 hour. That's 24 hour. That's 12-hour mode. The next one is a date format, and it's month, day, or year, or day, month, or year, month, date. So I think month, day, year is where I want it. 3 is leading 0 blanking, and if it's set for 0, it's lead 0 blanking, which is right. Night mode start hour 0 to 23. Okay, and that's the time it's going to start. That's setting number 4, 0 to 23. It starts at midnight. And the next one over is the 5th one. And it's either blank or dim. So enter it. Tubes off or dim display. Oh, I'm in the wrong mode here. This is the time. 05. That's the end hour. Okay, so if you want it to end at 7, so dim between midnight and 7, or dim between midnight and 8. There's that. Now the next one is parameter number 6. Parameter number 6 is tubes off or tubes displayed. Master blank start and master blank end. And then you can have it turn the display out completely. And option number 9 says when do you want it off? Weekdays, weekends, or all days, default. That way you can have it actually turn the display out if you're at work or something, so you don't. And then option 10 is neon colon mode. The default is both flash, and 0 is AM PM indication flashing, and 1 is AM PM indication illuminated. Both flashing, both illuminated. And right now they're both flashing. And here's some of the options for the different GPS and stuff, which I don't have to worry about right now because I don't have the GPS, so I can ignore that. And then some of the other things, I had to keep this. Slots mode. So we get to option number 22. And it's currently set for slots every 10 minutes, or you can have it slots every hour, slots at midnight, slots every minute. So every 10 minutes it'll go through the slot machine. That's to stop the burn or stop the cathode poisoning. And then you can set it for sync mode when it's going to sync. Display mode, and here's where we can have the digits, how the digits change. Either standard digits or fading digits with scroll back effect, which is what it's set for. Auto date display on or off, night mode override, and restore default settings. So I think we're going to leave it as it sits right now, and that takes me back to time. And that's it. It's done. Project is complete. The next time you guys will see this, it'll be mounted in its case. Now that looks cool. Watch. Yes. Gotta like that. Gotta love those real Nixie tubes. Nothing looks like a Nixie clock. And now that I've hey, perfect timing. It's going through the what they call the slot machine. This is to prevent cathode poisoning. So you just saw what it did there. It just does that at random. That's to prevent cathode poisoning. But there it is. As you can see what I've done, I put it into the case that I had the old vacuum fluorescent display module in. I think that looks choice. It looks fantastic. I'll show you the back of it. I made a back for it, and it covers it completely so that no light gets in the back, and it has a hatch for adjusting the time. I'll show you the back of it. So here's the back. It's made out of an old VHS tape box, right? Like you put like a rental movie would have come in, and I just got it cut to size, and I can just swing this up out of the way. And there are the adjustment buttons down inside here, so I can adjust the time. And then I just close that down like that, and that covers up any light getting in, and keeps it black in the back there, so that there's no light leakage, and it looks great. Now I admit this was an expensive kit. You know, there's no doubt about it that Nixie tubes certainly are not cheap, and it was an expensive kit to buy, but I think it's well worth it. It looks fantastic there on my desk. And in that solid, this is actually a walnut. I don't know, is it walnut? Yeah, I think it's walnut. Or mahogany. That's right. This is mahogany. I made this out of this box years ago. It looks fantastic. It's going to be a fixture in my office, and I love it. It's great. Always wanted one. Now I have one. That's even better because I built it myself. We'll catch you in the next one. Bye for now.